Hello, welcome back to the second part of Math 251 replacement class for Monday. Again, you do not have to watch any of this during the holiday. I'm not making you do work during the holiday. You can watch it on Tuesday, or you can even watch it on Wednesday before our class at 5 o'clock. So, all right, so we have done with equation of plane and equation of lines. These are some of the easier stuff, but now we want to look at some of the surfaces that is going to be a little bit more complicated. So let's say you have z equals to x squared. So we know for sure this is not a plane because of the square, okay? So how do we visualize it? So we are going to discuss the general techniques on visualize some of the surfaces that's going to be a little bit more complicated. So what we are going to do for this is that we can look at this like that. And we know that z equals to x squared. If you concentrate, so there's no y in it, right? So so you can say, all right, since there's nothing to do with y, maybe let's just think about what happened on y equal to 0. Y equal to 0 is our zy plane over there. And then, so since this doesn't have anything to do with y, so you can say, all right, let's look at this plane just for one particular y, so it's easier. So y equal to 0, how are we going to sketch this? Well, you know that the z is never going to be negative, so it's always going to be positive. It can be 0, and it's 0 exactly right here. So you have a kind of quadratic curve. It's not kind of, it's actually a quadratic curve, but on the zy plane. All right, so again, we are trying to do something, okay? We have to use your brain a lot because this is, think about it, this is actually pretty sophisticated, what your brain can do, because you are staring at a computer screen, which is 2D, but you can kind of see, imagine and visualize 3D objects. So this quadratic curve here, a parabolic curve, is actually on this plane, which is our our y equal to 0. Okay, so we're gonna have something like that. Obviously, I sketch part of it. I didn't do every single one of it. Now, this is true for y equal to 0, but if I say, all right, I don't want y equal to 0, but I wanted to do, let's say, y equal to 1. So this is a plane y equal to 1. So this is 1, right? X and z can be anything, but the y has to be 1. So how do you do z equal to x squared then? Well, if you think a little bit, you will notice that actually this is the same. We're just going to do it like that. All right, so it turns out that all these vertical cross sections, so these are what we call cross sections, right? So this is cross sections. So all these vertical cross sections is going to give you a curve that's like that. So you can imagine by putting it all together in your brain, your supercomputer, and you can, I think it's not too difficult for you to agree that these original 3D objects is like this. So z equal to x squared looks like this, okay? And we're going to slowly show you how you visualize this, right? So in this case, you visualize it pretty easily by doing the vertical cross sections, okay? If you wanted to look at the not vertical cross sections, but horizontal cross sections. So let's say you know how to do that. Okay, so now if you want to do, what you want to do now is the horizontal cross sections. So what would you be able to see? So every time when you, by the way, when you do horizontal cross sections, sometimes when you go lower, you can't see anything because you know that z cannot take negative value. So if your cross sections, let's say z equals to -1, you didn't touch the surface at all. But when you do touch the surface, you will be actually tracing out this line. So you actually have a line there, which is part of this curve. So you have another one right there as well. So you'll be seeing horizontal line like that. Not very useful visually. More powerful visualization is a vertical cross sections. Give you more idea here. But horizontal cross sections give you something that you can imagine too, which again, back to this picture, you can see, right? So if you have a horizontal cross sections, you will be seeing this kind of stuff, right, on both sides. But when you're doing a vertical cross section, you'll be seeing this kind of stuff, this kind of stuff. So we're basically, what we're going to do in general is we're basically going to do horizontal cross section or vertical cross section and see what you get and put it together using your supercomputer, which is your brain. All right, so let's look at another one. Okay, let's look at another example. This, we did it before. We did it actually in our first day of class, right? So we are looking at x squared. Let's look at another one. Let's look at, say, y squared plus z squared equals to 1. Y squared plus z squared equals to 1. So what is this? So we kind of already know. So let's just do it quickly. So if you look at y and z on the yz plane, okay? So now you take x equal to 0, you're on the yz plane right here. You know that this is going to give you a circle of radius 1 centered at the origin. And since this has nothing to do with z, right, if you do another vertical cross sections, you're also going to see this, you're going to go see that, and so on. And we already know that the shape of this, okay, the original shape of this is a cylinder, right? So it's a cylinder that is like this, for example, okay? So again, this time though, if you do your horizontal cross sections, you can also see that the horizontal cross section also give you lines, right? But vertical cross sections like that, it's going to give you circle. So again, putting these two together, you know that you have a cylinder. All right, now let's do something that is a little bit more complicated. Okay, now let's do something that's a little bit more complicated, and that is, let's say z equals to, all right, 4x squared plus y squared. So how do you visualize z equals to 4x squared plus y squared? You can continue the idea of doing the vertical cross section and the horizontal cross sections. Let's say this is x, y, this is z. We can also use our mathematical knowledge to notice that right-hand side can never be negative. These terms can never be negative. The smallest possible value is 0. It cannot be negative. So you don't even bother to think about what happens to here. You don't get anything over there. And you can actually, if you want, okay, you can think about what happened when z equal to 0. If your z is equal to 0, you have 4x squared plus y squared equal to 0. Not sure you know, but if you think hard enough, you will see that there's no other way to make this 0 unless your x and y are both 0. So it turns out if this is 0, there's only one way for your z is equal to 0, which is both x and y has to be equal to 0. Now, don't get yourself confused with this, though. You have to really think a little bit, because if you have x plus y equal to 0, x equal to 0, y equal to 0, these are one of the possibility, but I can have 1 plus negative 1 is still 0. None of that is 0, right? So I can have so many of them, right? 2 plus negative 2 and so on. I can have so many of it that both of them are not 0, but their sum is 0. The reason is because you can have something and then you can take away something. But when you have this, right, and then it's equal to 0, if you have some positive number here, there's no way for you to take away anything to make them 0. So that will have to really implies that both of them have to be 0. So let me say that again. 4x squared plus y squared equals to 0, okay? Basically, I'm looking at z equal to 0, right? So I'm saying z equal to 0. Z equal to 0 is a horizontal plane. This horizontal plane on the xy plane, right, that corresponds to z equal to 0. That graph, whatever this thing is, only touches the horizontal plane z equal to 0 at one point, which is x equal to 0 and y equal to 0. That's what I was saying. All right, cool. We also know nothing below it, so let's just go upward, okay? So let's say we do a cross section like that. So this is z equal to 1. So if you do z equal to 1 and you look at all the xy that satisfy this equation where z equal to 1, meaning that you have 4x squared plus y squared equals to 1, what do you get? You will get, if you still remember, right, you can write like this. If you still remember, this is an ellipse, right? So it's more general than circle. It's an ellipse. So it is an ellipse, and the shape is like that, for example. Okay, and if you wanted to go higher a little bit, so you say, okay, I don't want to do z equal to 1, but let's say I make another plane, which is z equals to 10. So what do you get? You get 4x squared plus y squared equals to 10. And then this, again, is an ellipse. Actually, it will be a bigger ellipse, okay? Think about why that's the case. We get a bigger ellipse. And then in fact here, if your z is smaller, you have smaller ellipse. So actually just using a horizontal cross sections, I already kind of know there's nothing down there. On top of it, it's just every time the slices that you have is you get the ellipse, bigger and bigger ellipse. So I mean, I'm guessing here, but pretty good guess is going to be something like that, right? It's kind of like a bowl, right? Okay, the things that you eat something with a bowl, that bowl, right? But this is weirder shape, but you get the idea, right? So it's kind of like what the hell I'm doing. I do have a picture for you, right? So you can see putting it together is not something that is very difficult to imagine, which is it's going to be something like this. Okay, it's going to be something like this. All right, since you already know how this thing looks like, we can, so, I mean, I don't have to do vertical slices, just horizontal slices. You already can kind of imagine that is the case. Let's do, just for the sake of doing it, let's think about what happens if you do a vertical slices like that, okay? So when you have a vertical slice like that, what do you get? So we have z, right, equals to 4x squared plus y squared. So let's say you do y equal to 1, right? So let's say you do y equal to 1, that's a vertical slice. So you have z equals to 4x squared plus 1. And what you get is that you have an equation, right here, which is a parabola again. And it is a parabola that go up a little bit. Their z value, look at the z value. The minimum z value is 1. This thing here cannot go even be 0, right? So the minimum number is 1. So it is basically a part of this that's like that, for example. It's a parabola. And now you know, this thing here, if you horizontal slice it, you get ellipse. Vertical slicing it, you get parabola. And you can kind of like figure it out that it has to be like a shape like this. Okay, so this is one of the very common shapes that you should know. And this is basically a generalization of your quadratic equation last time, right? So in high school, middle school, preschool, depends on I don't know, school system. So last time we have a quadratic equation like that, y equal to x squared or 2x squared or something like that. We have many different types. We also have, let's say, y equals to 2x squared plus 3. So we know here is 3 and so on. So this is like a 3D version of it. All right, so this is a 3D version of it. And this thing here has a special name. This is called an elliptical paraboloid. And I mean, mathematicians are not very creative naming stuff. The reason why it is called elliptical paraboloid is that when you do one of the cross sections, you get ellipse. You do another cross section, you have a paraboloid. So they call this an elliptical paraboloid. Okay, so when you have an equation like this, you have an elliptical paraboloid. By the way, this is just the beginning, right? So if once you understand this, I will hope that if I do something like this, y equals to x squared plus 3z squared, then you will know it's still elliptical parabola. It's just that the things changes, right? So how do you visualize this? One way is that you already kind of guess the shape is elliptical paraboloid, and now you know that the y cannot be negative, so it will be like this side only, and you know that your y equal to 0 only can happen when x and z are both 0. So you kind of already know it's different kind of stuff that go that way, right? So you have this thing, but you know, flip it around and you get that. So that's the idea. Once you get one, you will get the other one. So another thing I wanted to mention is the cross sections. So the cross sections, sometimes some cross section give you more insight. So I would think the vertical, for me at least, that the vertical cross section for me, kind of like, right? You remember when you do vertical cross section, you have that. So I can tell from that. Horizontal cross section sometimes it's hard. I just see a line like that and can't really imagine what that thing is. But vertical cross sections give me things like that, which is better for me. But that doesn't mean always vertical cross section is better though. So for example, in this case, actually I would prefer my horizontal cross section. My horizontal cross sections tell me more things than that. I just basically looking at the horizontal cross section, I already can kind of tell. So So depending on the object. So it depends on the objects. Sometimes vertical cross section is better. Sometimes horizontal cross section is better. And if you want, you put both of them together and see, oh, what is that? It's even better. But a lot of time we do know that just one vertical horizontal cross section, we already can kind of tell what that thing is. All right. Another thing is this thing here. This is again a general versions of an ellipse, right? So, or if you want to say, it's like a general version of a sphere. Sphere is a special case of ellipse. So what is that, right? So again, okay, let's do this a little bit so that you can kind of imagine this. All right, so this is going to be a little bit more complicated. It's not so much. All right, so okay, so let's take a look at this. Let's say I wanted to do a horizontal cross section. Okay, so I want to do a horizontal cross section like that. Obviously, from here you can already expect it. So we're going to get ellipses. Okay, now let's say we do it. Okay, how do you do a horizontal cross section? Well, your horizontal plane is z equal to something, right? So you just say, all right, I'm going to take z equal to k, all right? Some numbers. I don't know what that number is. Just do z equal to k. So rewrite this equation now with x squared plus y squared over 9. And then you have k squared over 4 equals to 1. This is a number. K is a fixed number. Move this across. X squared plus 1 over 9. Y squared equals to 1 minus k squared over 4. And immediately from here, you should immediately see that, this number here, right? This number here, it better be positive because this part here cannot be, all right, let me say that again. This part here should better be non-negative. It can be 0, but it cannot be negative, okay? Because this part here is non-negative. So from here, you can already see, in order for this to be non-negative, your k cannot be too big. Does that make sense? Okay, let me do this computation here. Okay, so what was it again? So we have the equations in the notes here was x squared. Let's do some algebra here. 1 over 9 y squared, okay, plus z squared equals over 4 equal to 1. Okay, so I'm setting my z equal to k. K is a fixed number, unknown, but a fixed number, so that become k now, right? K squared, move to here, you have this. And immediately you will see that there's some restriction here. What are the restrictions? We need this to be non-negative, which means if you cross multiply 4, so it means that 4 minus k squared, you need this to be positive. And in many different ways, depending on whether you want to do it like this and do the sign analysis to see what are the value of k that can make this happen, or you can also just based on your calculus, sorry, your algebra. So think of these terms here, right? If you try to plot these terms, this one here is like this, okay? But then it go up 4 units, so it's like that. So this is -2, this is 2. So you know that this thing here is positive only when your k is between 2 and -2, okay? Let me say that again. Do whatever you need to do to understand this, because some of you might use different methods. But what I'm saying is that this thing here can only be non-negative if your k is between -2 and 2. So now you know something. You know that for whatever this object is, if you go too high, let's say your z is 3, you don't get anything. There's nothing. If you do z equals to -5, you don't get anything either. But if you do z between -2 and 2, then this part here is actually a positive number, or if it's 0, and then this thing here gives you an ellipse. So that is a reason why. So there's a reason why that if you look at this picture here, you can see that your z value, it cannot go forever. It's the maximum z value you can see right here is 2, and the minimum is -2. That's how we figured it out. We can do analysis here as well. You look at the vertical planes. So if you look at a vertical plane, which means now you set the y equal to k, and then you do the analysis, you will notice that okay, the analysis is actually done over here. Let's say you set your y equal to k. All right, so now you look at this. Move the k to the other side just like before, and then now you know that in order for these things to have an image, right? So the k has to be between -3 and 3. So this part here is maximum 3. This part here is minimum 3. That is a little bit different from what we have seen before. But yeah, once you see that now, you can kind of can accept the fact that when you have things like that, it is going to give you a shape of an ellipse. So this kind of surface, again, we're not creative in naming stuff. This is called ellipsoid. Okay. All right. So what is the main takeaway? The main takeaway is that for visualizing this without using a computer, obviously you can use a computer graphics applications to help you with this, but you do need to know the basic concept of this cross section. It's going to be very helpful anyway. Now the last picture, let's do one more, and the notes have a bunch of other stuff for you to take a look at. But let's look at another one. This one here is complicated, harder to visualize. This is a surface that has equations. Let's say z equals to y squared minus x squared. All right, this negative here is complicating stuff. If this is plus, that's easy, right? If this is plus, that's super easy. What is that? That is just, right, we already know. This is like this. Z never negative, blah, blah, blah. Cross section is a circle, so you have that. So it's easy. If this is minus, things is going to be a little bit more complicated. So let's take a look at this one a little bit. Okay, so the idea, I'm not going to draw everything for you. You can look at the notes. The notes have a way much better way of doing all this stuff. But the idea is that if you, okay, let's do it. So z equals to y squared minus x squared. Okay, so let's look at the horizontal cross sections. Okay, horizontal cross sections, meaning we are setting our z equal to something. All right, let's say we are looking at the xy plane, which means z equal to 0. So when this thing is z equal to 0, you have y squared minus x squared. Move things to the other side. You have y squared equal to x squared. Take square roots. Your y is actually plus minus x. So this curve, if you do this surface, right? So this surface, if you do a horizontal cross section, z equal to 0, you will see this is the traces. You got two straight lines like that. Kind of strange, right? Okay, so let's say we go up a little bit. So let's say we go up a little bit. Let's say z equal to 1. So if z is equal to 1, what do you have? So if z is equal to 1, you will have something like that. And this, if you move this around, you will have y squared equals to 1 plus x squared. And then your y is plus minus square root of 1 plus x squared. So this is going to be something that is like this. Okay. Again, all right, look at this. Okay, so how do you draw square root of 1 plus x squared for y? Number one, this thing here has to be positive. It is always positive. But this thing here has a minimum value. The minimum value is 1. So the minimum value of this is 1. So your y here cannot go below 1. I mean, between 0 and 1, you can't have it. So it's going to be something like this. The other part, you can go from negative 1s to the other side, you have something like that. Does that make sense? So, so if you do a cross section on top, you get something like this. If you do a cross section, let's say z equals to negative 1, you actually will get something like that. So the horizontal cross sections give you weird stuff. Let me say that one more time, okay? So turns out that's this thing, z equals to x squared minus y squared. Is it y squared minus x squared? Y squared minus x squared. If you look at the xy plane, you get two lines like that. If you go up a little bit, you will get something like that. If you go down a little bit, go to the negative side, you will have this thing, but on the other side, you have something like that. So can't really figure out what this thing is yet. All right, let's try the vertical. Let's try the vertical cross sections. So if you do the vertical cross sections, okay, you do a vertical cross sections, same analysis, you will actually get a equation like this. Okay, let me show you. Okay, so z equals to y squared minus x squared, right? So suppose you said that this is my plane y equal to 1. So what is that? Z will equal to 1 minus x squared. So you know it's a quadratic equations that go like that. Maximum 1, so it's up there. And then this is a x, this is a y, and you have things that looks like that. Okay, let's say I go to the other side. Let's say what happens when your y is negative 1. So if your y is negative 1, you still have the same thing, right? Because negative 1 square, so you still have the same thing, so you repeat. It's symmetrical on that side, right? So it's symmetrical on that side. If you do closer, right, then this just means that this one is a smaller number, so it's going down a little bit, and you have a thing that's like that. If you do the other side, okay, vertical direction, but the other side, right, this side, like that, vertical direction, but this side, you will get a quadratic equation, but it's now going upward like that. So you can see it's a mess, right? Okay, so let's put it together, and let me show you what this thing is. So if you look at the notes, and you can see all the stuff that we talk about. So this is a good picture to look at. This is a horizontal cross section, vertical cross section on this direction, vertical cross section in this direction. The objects that give you all this stuff is what we call a saddle, right? So this is called a hyperbolic paraboloid. Why is it called hyperbolic paraboloid? Because we also not very creative for naming stuff. This kind of stuff is called hyperbola. This is, but this kind of stuff is called parabola. So you have hyperbolic paraboloid. And this object is actually just like, they call it saddle. We will use this terminology a lot as well. So this so-called saddle is, so it's called saddle because, okay, think about that. So you have, I don't know how to do this, but it's a horse, okay? Right, so this is a saddle. So if you go this direction, all right, if you go this direction, the things will go down like that. All right, okay? If you go the other direction here, things will go down. But if you touch the front part of the horse like that, right, the things will go up, right? And then you touch you go backwards, like touch the back part like that from the horse, things will go up. This, okay, is a 3D version of your equation y equal to x cubed. So remember y equal to x cubed, okay? Let me see right here, it's a terrible horse. Yeah, you know what I mean. Okay, so the y equals to x cubed, right, is equations that in calculus you encountered this before. Is a graph that's like that. That we don't have a minimum at this point. We don't have a maximum at this point either. So this is not a minimum because I can find something smaller. This is not a maximum because I can find something bigger. Same with this. So this is not maximum, that's not a minimum, because this, if this is a maximum, that's not true because I can move a little bit higher, I get something that's bigger. This is not a minimum because I can go somewhere here, I can find something smaller. So this is 3D versions, XYZ versions of our equation y equal x cubed. They kind of have that feature. So remember that this is called saddle point last time, right? The derivative is equal to 0, but then you don't have a maximum, you don't have a minimum. Same with this thing too, okay? So I will direct your attentions to the other surfaces that you are seeing here. This has names called the quadric surfaces. Quadric surfaces is just any surfaces that can be written like that in general form. So we have been investigating some of the very typical quadric surfaces. This is a table of the things that you have. So we have ellipsoid, we know elliptical paraboloid, we know hyperbolic paraboloid, we know cone, hyperbolic paraboloid of one sheet, hyperbolic paraboloid of two sheets. The analysis is the same: cross section, cross section, cross section, cross section. You will have to try it to see it, okay? So, all right, this is it. So when we come back on Wednesday, we will start a new section which is on 13. We'll basically go to a new chapter now. So on Wednesday when we come back, we will be going to chapter 13 to look at vector value functions and space curve. And that's it. Thank you and good night.